All right, back again with part 4 of the STAAR Geometry practice test answers 31 through 40. On question 31, we have triangle QRS. It tells us segment RT is an altitude. Obviously, we need to know what an altitude is. Property of an altitude is basically the height of a triangle. It goes from one vertex and is perpendicular to the opposite side is that property. So we should be able to draw in there the only property we know for sure about an altitude. Which additional condition would not be sufficient to prove that QR is equal to SR? So would not be sufficient to prove that these two pieces, QR and SR, are equal. Okay, so T is the midpoint of QS. If these were equal right here, then I would be able to say that these were congruent by side, angle, side. They both have a side of 3, a right angle, and then a shared side in the middle. So that would be enough to prove that these are congruent. So then the other pieces, the hypotenuse would have to be congruent as well, because CPCTC would prove that those are congruent. So if I can prove that the two triangles are congruent, then that would prove the two pieces. And I could prove that one using side, angle, side. So yes, that one works, side, angle, side. Congruency. All right, what about RT bisects angle QRS? So let's erase that piece that I just added on there. And say, what if RT bisects angle QRS? What if these angles were congruent? Well, then I would have an angle, a shared side, and then an angle. That would work by angle, side, angle, proving the two triangles are congruent. And then these last two pieces would have to be congruent by CPCTC. All right, what if TS equals 2? Okay, TS equals 2. I don't think that's going to help, because then the triangles wouldn't be congruent, so then we couldn't really do much with that. So I'm not sure about this one yet. And then what about D? What if RT equaled 4? So if RT equaled 4, then because this is an altitude, it's a right angle, you could do Pythagorean theorem and prove that 3 squared plus 4 squared is 9 plus 16 is 25. Square root of 25 is 5. That does show that that last piece has to be 5. So this one does work. So which one is not enough information to prove those two pieces? C is the one that is not enough information. On 32. Lines RT and V intersect as shown to form an isosceles trapezoid. So A, B, C, D. So I have trapezoid means that one pair of opposite sides are parallel. Isosceles means two legs are congruent. Which expression represents the measure of angle 1 in degrees? Interesting. So how do we figure out angle 1? So I see there is one angle over here that is represented. It is vertical with this one. And I do know that in an isosceles trapezoid, the base angles are congruent, which means these two base angles on the trapezoid on base AD down there at the bottom do have to be congruent. So both of these two angles are 7y minus 4. So now if I look at the big triangle that includes angle 1, it has two base angles of 7y minus 4, 7y minus 4, and then the vertex angle would be 1 up there. So which expression represents the measure of angle 1? Well, 180 minus the two base angles, which are both 7y minus 4. So this one definitely represents angle 1, because that's exactly what we came up with. 33. A banner is composed of two congruent triangles and a rectangle as shown. What is the total area of the banner in square centimeters? So let's just find the area of the two triangles and the area of the rectangle, then add them all up. Okay, so it looks like I have a triangle over here. So it looks like I can just add the area of 2 of those triangles and 1 rectangle. The area of a triangle is 1/2 base times height, so just need the base and the height of the triangle. Area of the rectangle is base times height. Got those dimensions there. So all we got to do is plug in now 2 times 1/2. Those actually cancel out. Base and height of the triangle are 10 and 12. Base is 10, the perpendicular height is 12. And for the rectangle, base times height is 10 and 12. Or 12, or whoops, 17. 10 and 17. You could switch those, doesn't matter, 17 and 10. In any case, let's go ahead and plug that in our calculator, 10, 12, and 10, 17. 10 times 12 plus 10 times 17. We end up getting 290 for our answer for that one. So the total area should be 290 square centimeters. 34 says the front, side, and top views of a three-dimensional figure are shown made identically. Keep showing which diagram represents the three-dimensional figure. So looking at the top, looks like I do have a square here with an extra piece sticking off on the bottom right, below, and to the right. So looks like this one could have the correct top view. Same thing, I have a square here I can see with those same 2 pieces. So this one meets the top view. I don't see that extra piece sticking off right there. That should be there. But this one does have that. I've got this, and then I've got an extra piece here and here. So I've already got rid of this one. What about the front view now? So for the front view, I need to make sure that I have across the bottom 4 wide, and then I see 2 in the middle here. So across the front, I do see 1, 2, 3, 4 in the front, and then the 2 in the middle do have stacks that go up 3 high. So 3 high. So this one meets the front view. Same thing here. I see the bottom row across the front. I'd see those, and then above the second and third row, I do have these back here that I could see. So that one meets there. And this one, the second row only goes up 2 high. So you needed another block here to be able to have 3 high in there. So I don't think that one's going to be the correct front view there. So it's just narrowing down to these. From the side view, it should be the first one sticking out is 1, the second one is 2, and then 3, 3. So from the side view, you could see 1 here. From the second row, you'd see 2, and from the third row, you'd see 3 and 3. So I'm pretty sure it's this one. Here on the second row, it's not too high. It's supposed to be 2 high right there. It's supposed to go from 1 to 2 high to 3 high to 3 high. So definitely not that one. It should be F. Sorry for all the ugly marks I put on there, but it is F. 35. First 4 stages of pattern arcs from congruent circles are shown below. If this pattern continues, which expression can be used to find the degree measure of the arc in stage N? So basically we have stage numbers and we have values that represent the degree. So notice on this first one, you can either think about how this is being multiplied or added or subtracted, or what exactly is happening. So it looks like it goes down 60 degrees, but then only down 40 degrees, and then what's 26.6 degrees? I don't know exactly what happened there. So it's not a constant amount, so it's not going to be some linear expression like this one. However, if I take 120 divided by 180, and I get, what is that, divide both of these by 60, I get 2/3. Maybe that's a constant factor. Is that going to be how I can get this? If I multiply by 2/3 for the degree measurement, do I get this? What is 120 times 2/3? So 120 divided by 3 is 40 times 2 is 80. So yeah, that does work. What about here? 80 times 2/3. Let's check real quick, see what we get. 80 times 2/3. 80 times 2/3. I do get 53.3. That's exactly what I got on there. So I think each one of these is just being multiplied by 2/3 over and over and over again. So which one would be? I see this one has a 2/3 in it. And as the stage increases, that just means that I'm going to apply this 2/3 another time. So notice what happens here if I plug in a 1. So let's say f of 1 equals 270 times 2/3 to the first power. The exponent just tells you how many times you're going to apply this 2/3. So 2/3 of 270 is 180. So if I plug in a 1 on the first stage, you do get 180 on there. If I plug in a 2, that means the 2/3 is going to be applied 2 times. So I'll take f of 2, so stage 2 should equal 270. And what this is really doing is 2/3 to the to the second power really just means it's 2/3 times 2/3 is 2/3 times 2/3. And when you add another degree, you'd be putting another one on there, and you'd be applying this 2/3 again. So that it really just tells you at what stage we're at, the first stage, the second stage, the third stage, how many times you're going to multiply by 2/3 again. So if we kept going, this would represent the pattern. And if I do multiply this in the calculator, I do get 120, then 80, or excuse me, I get 120, then 80, then 53.3, because we literally already multiplied by 2/3 again, and then again, and again to see what we get. So answer choice D on that one. All right, 36 says in the figure below, K is parallel to T, so they look parallel. Let's go ahead and label them. The extra set of arrowheads here indicate that they're parallel. And K is perpendicular to Q. So K and Q are perpendicular. Luckily, they look like it, but I'm going to go ahead and add that. Based on this information, which statement can also be proven? Angle ACB is congruent to angle ABC. So ACB is this angle here. Is congruent to ABC, this one here? No, I don't think so. Those are created by 3 lines, 3 different lines right there, not parallel lines cut by a transversal. So that's created by this line, this line, this line. None of those are parallel to each other, so you can't use parallel lines cut by a transversal, so definitely not that one. What about CAB is an acute triangle? So CAB is an acute? I don't know, might be, might not. I don't know necessarily what this angle is right here. Actually, I do, because these are parallel lines here cut by this transversal, and these are alternate interior angles. So it's definitely not acute, it's a right triangle. So that's not true because it said it was an acute triangle. Next one, angle, let me get rid of some of this here. Angle DCB, so DCB is this angle here, is equal to angle BCA. So BCA, are those 2 angles congruent? No, I don't think so, because R could go any different direction. Doesn't really tell us about there. Those angles could change. Don't think that's true. And angle CAB is a right triangle. Yeah, that's true, because of these alternate interior angles we just talked about. It's got to be J on there. This angle here is an alternate interior angle. On these parallel lines cut by this transversal. These are alternate interior angles, so they have to be congruent. 37. The main entrance on the Louvre Art Museum is shaped like a pyramid. The pyramid is 71 feet tall and has a slant height of approximately 91 feet. So 71 feet tall, slant height of approximately 91 feet. Each side is square with 115 feet, so 115 it is a square, so that's convenient. Which of the following is the closest to the lateral surface area of the pyramid? So on your formula chart, you have a lateral and a total. The lateral surface area from your formula chart is equal to 1/2 PL, and we don't need to add the base for the total surface area, so it's just going to be 1/2 PL, perimeter of the base, times the lateral height. So let's go ahead and plug these in. 1/2. Perimeter of the base is going to be 460. We get that by adding these up. 115, 115 times 4 is 460. And the lateral height is 91. That was given to us. slant height and lateral height are the same thing. So yeah, 1/2 460 91. Let's plug that in the calculator. 1/2 times 460 times 91. We get to 20,930. So 20,930. Answer choice A. Exactly what we got. Square feet was surface area. Yep. 38. Companies designing a flotation device made of foam. The shape of the design is modeled below. So we have this interesting shape here. Which net can be folded to form this flotation? So basically, what shapes do we see here? So there's an obvious small rectangle here. On the bottom, we have these shapes that look kind of like a rectangle with a semicircle on top. Oops, there's some ugly ones here. So basically this shape here, there's two of those, so we should have two of these. So right now we have one small rectangle, two of these, and then this lateral surface that goes around the edge should just be one big rectangle, and there's one of those. Okay, so I have 1, 2, 3, 4 total surfaces that I would need on there. There's one. This looks reasonable. Okay, so I see here that this first piece matches up with this one because it is touching at the corners there, that wrap around on the sides. Whoops, it is touching there and there. And then it does have these two pieces, so there are two of those. And then I do have one long rectangle that wraps around. If I folded those over and wrapped it around, it should make that shape on there. So answer choice G does have the right number of correct pieces. This one has 1, 2, 3, 4, 5, and it doesn't have the piece that would need to wrap around here and here to connect. Same thing here. This has 1, 2, 3, 4, 5. Although this piece could be cut in half, those aren't long enough to completely wrap around the edge there as well. And this one has 4, but the short rectangle piece is not in the right spot. So, when you fold these two pieces together here, you should have some other fold, and it's got to be long enough to wrap around the edge as well. So answer choice G. On 39, diagram shows the arcs and segments used to construct triangle ABC given line K. Based on this construction, which statement is not true? So first of all, they used a compass to be able to start at W and make these arc measurements. All right, so let's look about some of the properties of when you use a compass. So this is the center of a circle, and this would be like the radius of a circle here, which means this distance is the same as this distance here. So this W is right in the middle. That is the midpoint of segment AB. So it's going right to the middle of that. From arc B and arc A, they created some more arcs that are the same distance away, which means the distance that they used to create this arc and this arc is the same distance. So these two legs create an isosceles triangle. And since we drew this to the middle of the isosceles triangle, that means it's going to be the perpendicular bisector as well. So first, let's go through the things that definitely are true. CWB is a right triangle, because if you connect the altitude, or if you draw the height of an isosceles triangle that goes to the midpoint, it does make it perpendicular. That's definitely a right triangle. ACB, the big triangle, is isosceles. That's true. These two pieces are correct because those arcs were made from A and B to create that. And then the measure of angle CAB down here, CAB is congruent to CBA. Yeah, on an isosceles triangle, the base angles are congruent. So the only one I wasn't sure about would have been then that, let me get rid of everything except for the important stuff, AWC, this angle here, is complementary to CWB, this angle here. No, complementary means two angles that add up to 90. These two angles add up to 180. These are supplementary, not complementary. So it should be answer choice A on that one, because that is not true. On 40, here we have a parallelogram ABCD. It's transformed to create parallelogram A prime, B prime, C prime, D prime. So we started here, we did some transformation, and we ended up here. Which rule describes the transformation that was used? Okay, so it looks like there was some sort of reflection across, because B was on the left, now it's on the right side, so looks like there was a reflection, and clearly it moved down as well. Did it go any farther away? Looks like C was 4 units away. It's still 4 units away, so it looks like maybe they reflected over the y-axis and ended up over here, and then translated down some for that. So let's look and see which one of these says that. All right, so reflecting over the y-axis, the y values would actually stay the same, and the x values get opposite. So the x value, like what was a -7, should have got reflected across and become a +7. So the original thing, I know the x's are going to be opposite from what they were, and the y's stay the same to do the reflection. Once they get reflected over here to this point, and C was at 7, so 7, or B was at 7. Then they need to move down, and the y value would be changing. The y values need to translate down 3 units. So y -3 will get you that new coordinate. So it should be -x, y -3 to do the reflection, and then translate the y values down 3. So -x, y -3 does exactly that. If you weren't sure, you could write down the coordinates and apply the rule to the original coordinates to see if it gives you the prime coordinates for each one, A prime, B prime, C prime, D prime. So take the coordinates for like A, apply the rule, see what the coordinates are, make sure it matches up is another way to do this one. Just takes a lot longer to do it that way. All right, that is question 40. So we're done with 31 through 40. See you guys for the next video.